So for this, the focus is still looking at what are generally considered two-step equations, but with a few more fractions. And I just want to mention a few more strategies as you start dealing with a few more fractions involved in your equations. So I have just two examples. And as it says at the top, the only sentence, when solving equations involving fractions, it is often helpful to multiply both sides by the lowest common denominator. And so, but again, notice it says it's often helpful. None of these are rules you have to do. But if you look at either of these equations and they look a bit more daunting to you than what we did in the last lesson, then it's probably a good idea to get rid of these fractions right away. So for example, if I look at this equation, again, eventually I want to solve for x. I have a couple denominators. They are the same thing though. That's nice. So both denominators are 5. So the lowest common denominator is 5. And so if I multiply everything by 5 right away, I guarantee I'll immediately have no fractions left. So for example, if I multiply this side by 5 and multiply this side by 5, again, I can multiply both sides by essentially any number I want, as long as I do the same thing to both sides. So if I look on the left-hand side, what do I have right here? Because really, I'm kind of distributing the 5. I have 5 times 2x. I'll change that time symbol to a dot, so I don't think it's an x. I have 5 times 2x, which is 10x, but then divided by 5. And 10x divided by 5 is 2x, which is notice what I just have in my numerator. And that's not a coincidence, because if I'm multiplying 5 times 2x over 5, I can also just see that these are going to cancel each other out. So in the end, I know this is going to simplify to just 2x. But that's it, there's another term on the left-hand side. I also have to think about what is 5 times negative 1/5. And again, I could do the same thing. I could think of it as 5 over 1, multiply top, multiply the bottom, and I get negative 5 over 5, which is the same as 1 whole. Which again, I could see I could see right away, because I can see right here that if I have 5 over 1 times 1 over 5, these 5s are going to cancel out, and I'm left with just negative 1. So however you want to think about this, in the end, I guarantee this will always work. If you multiply both sides by the lowest common denominator, you will immediately have no fractions. If you look on the left-hand side, all I've left is 2x minus 1. But I got to make sure I also remember to multiply the right-hand side by 5. That's it. Negative 10 times 5 is negative 50. All right, and now I have an equivalent equation that I think is much more pleasant. It's kind of analogous to how the last video ended with, we had some decimals, and I said if you want, you could multiply everything by some multiple of 10 to get rid of the decimals. You really, in many ways, give yourself an extra step, but you just make your equation look more pleasant, more friendly, and that's, I think, a good idea right here. And now, this is no different than anything we saw in the last lesson. I'm going to add 1 to both sides. So I have 2x equals negative 50 plus 1 is negative 49. And I want to know what 1x is, not 2x's, so I want to divide both sides by 2. And so I have negative 49 divided by 2, which is going to be negative 24.5 if we choose to decimalize it. Which again, we could leave it as a fraction, but chances are you'd prefer to decimalize it. I will say before I go on, it would not have been wrong in the very first step to actually just add 1/5 to both sides and start something like that. And you should eventually get the same answer. But again, if we are multiplying both sides by, in this case, 5, the lowest common denominator, we can always immediately get to a step where we have no more fractions. Always, always, always. Because all these things cancel out. So let's look at one more example right here. Now here I have I have 2 different denominators, and I have a mixed number. First thing I would do is change this to an improper fraction. And so 1/1/5 is the same as 6/5. Remember, whole number times the denominator, add it to the top. So 6/5 equals 2 minus 2x over 3. OK, so now I have 2 different denominators. I have a 5 and a 3. So I want to multiply both sides by 15, because 15 is the lowest common denominator of 5 and 3. So I can multiply this side by 15 and multiply this side by 15. All right, so let's look at the left-hand side first. I could think of it as 15 over 1 and multiply the top and multiply the bottom, or what I'd actually encourage you to do is to realize that 15 over 5 reduces to 3 over 1. And so really all I have here is 3 times 6, which is 18. And I'd highly encourage you to think about it like that. You give yourself less work, simpler numbers, and again, this is always going to happen. If you really are multiplying by the lowest common denominator, your denominators should always somehow completely cancel out. On the right-hand side, I have 15 times 2, which is 30, minus 15 times 2x over 3. But again, I would immediately recommend just realizing that 15 over 3 reduces to 5 over 1. So really all I have to think about there is 2x times 5, which is 10x. And so notice by multiplying both sides by 15, I'll kind of just go back to how I had it originally. Right, I multiply both sides by 15, and I get to an equivalent, but I think more pleasant equation. Now, fairly routine. I want to figure out x, and I know, I got it. It'll take me 2 steps. First, 2 more steps, I should say. I'll subtract 30 from both sides. So on the left-hand side, I have negative 12. 18 take away 30. Again, really easy to make mistakes with negatives, but 18 take away 30 is negative 12. And on the right-hand side, I have negative 10x. And so lastly, to figure out just what 1x is, I need to divide both sides by negative 10. And so on the left-hand side, a negative divided by negative is a positive. 12 divided by 10 is 1.2, and that's just 1x. So like before, lots of approaches. Notice in this case, because I decided to multiply both sides by the lowest common denominator right away, most of these questions here took me 3 steps. But again, we don't want to get too hung up on it. It has to be 2 steps.